after this, because the previous video shows about only the diagram, is it right? And now I should have to come back to the complete expression, is it right? And now we look about this one, G, C, some more parameters available, right? And you know about the electrical component, the RLC, because R is resistor, L is inductor, C is capacitor, right? But now I'm going to have the new term for this transmission lines, and the new terms are said to be two new terms, Z as well as letter of Y. Here, what's the thing means? Z is the relation from a resistance, and Y is the relation from the conductance. Okay, I'm going to write the Z as well as Y in the form of two-way. Okay, so before that, I'm just entering and just want to rub up the diagram. So you have a, I hope you might know about this diagram. You have noted this diagram. From this diagram, you can know about more things. As we are going to complete this expression with this diagram, please do clear about this diagram. If you have any doubts, you just make a comments in the comment box on YouTube, and then I just go forward. Okay, now I do rub everything, and we're gonna initiate about Z as well as Y. Okay, and that's very more important over here. And now what I do, I told Z right. Z is a companion of R and Y is a companion of G. That means what is about the resistance as well as conductance. So I do write Z in the form of, I told it's a relation of R, right? R, okay. But, and then afterwards plus R plus J omega L. J omega L. You don't want to mark up, okay? Markup is a very worst thing in my case, okay? Because right over here, everything's a bit practical. Whatever happening in the world, that we are studying already, okay? So J represents, because in a resistance, it is going, is it right? So one house may get one power supply, and that same power supply cannot be get by the another house, but these two houses shares the same transformer circuit power supply. Okay, so one house, suppose if my house is receiving only the 300 volt, sometimes because it may be variation, right? 240 watt maybe coming 300, next house may be getting around the 280 watt, likewise that like something more change. That's why I got a J, and omega is about the having a passing of electrons with respect to the wave, because when you go for electrons, E minus also is going in a wave form. That means what sinusoid wave. That means what is about the 2 pi. So one frequency is equal to 2 pi, is it right? So 2 pi of is equal, omega is equal to 2 pi of. So I have say about omega, and then L, it represents a small such type of resistance, or it may be small at a time. At a particular time, it is saving something, and then it is leaving something. That is why I got a L here. Okay, inductance means what? It's not about storing for a long time, but for instantaneous time, it is getting stored, and then it will be leaving everything. And now we're going to go for this Y, and Y is equal to the next one, and a simple opposite of everything. That's the word opposite is what, G, and then afterwards plus G plus J omega C. So just opposite. That's why opposite. And then we go inverse. So opposite of R is what, G, or otherwise we may go for inverse of R, and then we go for J omega, and this L as well as of C. Okay, and now what I do, we will go for this voltage drop. Now what is the voltage drop means? I hope I should have to get the diagram at the corner. Okay, so if we just draw the diagram, first one will be of what, resistance as well as inductance, is it right? And then afterwards we may go to next one. So this may story here. First one inductance, and afterwards resistance, and afterwards there will be a supply, and here conductance, and then there should be a capacitance, and afterwards it may go, and then now here once again it may go for this inductance, and after resistance, and afterwards we go, and finally it is come over here, and here the measurement is V plus dV, and here it's V, and the total distance is dx, and after this is about the G conductance, and this is about the L, and this is about the R, and it's about L. So here the power current supply is I plus dI, because you all know that V is directly proportional to I. Suppose if the V plus dV means there should be of what, I plus dI, and that's very more important here. And if there comes a V here means there should be of what, it should be I. Okay, so because as per the Ohm's law, the voltage is completely proportional to that of I. Okay, and that's right. Now what we do, we may go for applying of this Ohm's law. So you're gonna go the first one, V plus dV. Okay, and now what I'm going to do, I'm going to eliminate, because I want to know about the complete voltage from the transformer. So I just remove the house house voltage. Okay, I'm just removing the house voltage. So the same thing what I have equal to, we apply the form of V is equal to IR. Okay, so how do I write? I just want to write, because now I'm going to find about the voltage. Is it right? I into, what's the term of R? Because I told that in terms of transmission line, I'm going to make a R in the form of EZ. And now we take about the EZ here. What's EZ? So usually you used to get IR only, but right now we are doing about the EZ. And so the next step is equal to I into R plus J omega L. So V plus dV minus V is equal to this term. I got it, is it right? And about the next one, what I do, I'm going to have the same expression for this afterwards. So what I do, I got this elimination of both things, and then I have a dV only, and dV is equal to what I got it. I got the I into, and what I do, I'm just going to multiply. So that will be a more good for me. Basic multiplication is more and more and better for me. So what I have, so here I want to have some more things about this. That is, dx should be taken, because this distance is very more important for any calculation of voltage, because voltage has to be varied with respect to distance. Because when you have the house near to someone, because over here, when you have the source and when you have the receiver somewhat closer, the voltage is very high. Example, if you have the pin, and if you the pin and if the magnet is very closer, the attraction is very high. That means the power is very high. Power of the magnet is very high. And when you got the pin away, that means the distance is going very high, increasing. The power is reducing. Is it right? So that's why. So with respect to distance, the voltage is increasing or decreasing. So that we should add the df. Then only you know about the voltage, whether it's right or not. It's going and increasing or anything. Okay. And it is going to go. So I into R plus J omega L. I just write one more time. So this R plus J omega L into and dx. And what I do is just going for dV by dx. Simple form, dV by dx, which is equal to. So what I do is equal to I into, what's this? If I just have this over here, means y into z. I got it simple, is it right? Now what I do is just to make it the form of this one, d by dx, you just make it as the form of equation number 1, and you make simply as it is. When I see the next video about this one. Thank you.